Hey students, welcome back to another geography lesson with Mrs. T, and we are finishing up chapter 4 in this set of lessons. Let me see, we're starting in my textbook, which is, I'm using the 12th edition. It starts on page 92, the section on land and water temperature contrasts. And so we're going to look at the effects of solar radiation and insolation on temperature of land and water. Now, we jumped ahead to chapter 5, so we've covered the topics in chapter 5 already, where we look at atmospheric motion and the different kinds of waves and the different kinds of currents, air currents, that exist around the world, around the globe. And in this section of chapter 4, we're going to continue to look at circulation, but instead of atmospheric circulation, we're going to look at ocean currents, for instance, and the way that heat is either stored or transmitted or radiated from different types of things on the Earth's surface or below the Earth's surface. And so we're going to look at, I've just got this graphic behind me because we've studied so far. This is a review, this graphic behind me. So far, we have reviewed how incoming solar radiation goes through the atmospheric layers. And in some of the curated videos that you are required to watch after you finish this one with me, we're going to revisit how the Earth is tilted on an axis, an imaginary line called an axis, and how it revolves around the sun and creates the seasons of the year, of course. But we're going to go deeper and learn how that doesn't merely affect the air around us, in a variety of ways, depending upon whether the air has a lot of water vapor or is very dry or has a lot of different kinds of gases in it, like methane, or the density and pressure of the gas is different. We know that all of those variables affect the way that air is going to flow and move or store and transmit energy. And some of those same things, those same properties like density and pressure and temperature, some of those same properties certainly do affect the way that water flows around the world in the ocean. And so, of course, all of us know that water is a fluid substance. It flows in the same way that we study air as air flows. We use the same principles of physics to look at the atmosphere that we do to look at the oceans, for instance. And so there's a wide variety of chemicals and substances that make up land masses, and there's also a wide variety of things that can be found in water. For instance, salt water, and the density of salt water can affect certain ways that water moves in the ocean. But in this part of chapter 4, we're going to look at heat transfer and energy transfer from the sun specifically, and how it affects motion within the water on Earth. Okay, and so there are some specific properties that we need to consider in addition to, the rotation and the revolution around the sun and the angle of incidence of the rays of sun on the surface of the Earth. We need to look at the way that the chemical properties like specific heat, which is a vocabulary word for this chapter. Specific heat is it's the reason a cast iron skillet is hot and stays hot all throughout it, and you can't just grab it with your bare hand and expect not to be burned yourself. Specific heat is the amount of energy needed to raise something or lower something by 1 degree Celsius. It's the amount of energy that it takes to do that, and it takes a lot of energy to heat up that cast iron pan, and it's going to cool slowly too. So even if you get it out of the oven or you take it off the stove and you've still got your cornbread in it, you got to wait for a while before you can handle it without those oven mitts. You might grill outside quite a lot and use aluminum foil. And aluminum foil is very different than that cast iron pan. You can have that aluminum foil right over the hottest part of your grill, and in a matter of seconds, literally 10, 15 seconds, it is cool enough to touch it with your bare hands. Just the aluminum foil, not the stuff inside of it, but just a piece of aluminum foil, because aluminum has a very low specific heat. It takes very little energy for it to change its temperature. And so this is a concept that we have to investigate in physical science because we are looking at this radiant energy from the sun coming into our atmosphere, and it doesn't just all get absorbed by the air. It doesn't all bounce back by the properties of the ozone layer, for instance, and the greenhouse gas effect. It doesn't simply come in and all it does is affect the air mass around us. It affects the land mass, and it also affects our water quite a bit. Water has a much higher specific heat than land does. So land heats up, particularly the surface of the land. It's going to heat up and radiate energy from that land and feel very, very warm much quicker than water does. Water has a higher specific heat, so it takes about 5 times as much energy to heat up water to the same temperature as it does the land surface. And of course, the land surface is, going to be made up of different things in different places. If you've gone to the beach and you walk barefooted on the sand and it's very, very hot on the top of the sand, but you dig your feet down into it, it's cooler down there where you can get away from those sun's rays. Or if you've run around the swimming pool on a hot surface of concrete and you ask somebody, please splash some water up here on this hot concrete. And that's because the evaporational cooling of that water can really affect that surface. Think of the concrete as land. Of course, the sand is one of the ways that land can be composed, one of the compositions land can take. And so land can cool at a much quicker rate than water does. Land can heat up at a much quicker rate than water does. And water also transmits energy much more thoroughly than land does. Land is completely opaque. It means you can't see through it, and that means light. The visible light that we learned about in the previous lessons can't travel through it. Water is very clear water, especially if it doesn't have a whole lot of pollutants in it. Water can transmit light all the way down to the bottom of the ocean. If you've ever been in the Bahamas, I know some of you have, or in the Caribbean anywhere, some of you have because you've told me on the discussion boards, you undoubtedly were able to go out on a boat or go snorkeling or walk around on the beach, and you can see clearly all the way through the water. It's the bluest, most beautiful water, and you can see everything around because water transmits that light and also the other energy from the sun, the long wave and the short wave radiation from the sun, just as easily as it does that light. And so these are some of the properties that land and earth, you can compare land and water on the earth. You can compare them using these properties. For instance, transfer of energy or mobility of a substance, like the air. We've talked about all of the circulation patterns of the air. Well, land clearly doesn't have mobility as a feature, not by itself. And water is going to be greatly affected by the heat that's created by the sun's radiation. And so it's going to be mobile. You're going to have ocean currents that we learn about in this particular section of chapter 4. We're going to talk about upwelling of cold water from the bottom of the ocean to the surface, and warm water taking its place, and having those kinds of vertical transmissions of energy, and horizontal transmissions of energy through advection, for instance, through the ocean, usually caused by the currents, residual currents from that upwelling, but also from density differences with, high saline content of water going to a lower saline content of water, and mixing happening that way. And so as you're reading through this last section of chapter 4, I'm looking to see how many pages. It's about 16 pages. You will be learning some additional information and some review about the atmosphere of the earth and how, the position of the sun, the seasons of the year, the angle of incidence of the sun's rays are going to affect the atmosphere. But we're going to include or expand to talk about land and to talk about water also. And water is one of the focuses. We have the atmosphere, we have the lithosphere, which is going to be land masses, we have the hydrosphere and the biosphere. So land and water, this is not the first time and not the only time we're going to talk about them. We're going to include them in our conversation moving forward. And in the next few lessons for this particular unit folder, we're going to look more into that water cycle. We're going to look at motion and energy transfer that water possesses. And it's the fluvial process. How does water move in rivers and this kind of thing? And for our unit assignment, we're going to look at some very interesting concepts that are being floated around in science lately about that solar radiation and how perhaps we can harness it in a different way that maybe you haven't heard of before until you took this class. I'm not just talking about solar panels and solar cells and things that we can use to run our cars or our homes or our boat motors or any of those kinds of things. But there is some new experimental science that has pros and cons. It's highly in debate about how do we harness, capture, redirect, etc., solar radiation to affect perhaps global warming and climate change that we can measure. Certainly, since measurements were made, we can measure that climate change is definitely happening. Just look at some of the topics that our favorite movies cover, like the Ice Age, right? Certainly there was an Ice Age and climate changed. So we are still currently moving out of that Ice Age. And so the issue of climate change is not a political one in this class at all. It's obviously measurably, observably happening. And some people in our society today make a political issue out of how much you and I affect that anthropogenesis that we learned that word 2 or 3 sets of lessons ago, 2 or 3 chapters ago, how much anthropogenesis, meaning man-made effects, are accelerating that climate change, the climate change which is inevitable in and of itself, whether we existed here or not. So we will be looking at all of these things. It's a very interesting group of lessons that we have in this unit, and I hope that you will text me with questions and that you will enjoy the curated videos that I have for you. Some of them I have queued so that they start, not at the beginning, but inside the video for the portions that I particularly need you to spend your time learning with. And so enjoy them, write excellent reflection journals about these topics. Oh, and one of the questions that I thought might interest you to do a reflection journal with a little bit of research behind it. In one of the videos, I think it's the TED education video, we talk about the perihelion and the aphelion of the position of the Earth in relation to the sun throughout. It causes it's the distance from the sun that happens as the months pass. Sorry, I'm getting tongue-tied. As the months pass, the seasons of the year. And so the Earth at some point is closer to the sun, and at other points it's farther away from the sun. It doesn't cause the seasons of the year, but it corresponds to the seasons of the year. But you could look at, for instance, when is it summer in the northern hemisphere and when is it summer in the southern hemisphere, and try to make a guess about whether the summers are easier to deal with where we are in the northern hemisphere or harder to deal with here than it is for our neighbors in the southern hemisphere. Try to make a guess after you have consumed this information and taken notes. Try to make a guess about whether it's hotter here or there, and then do a little bit of research and see if you can find some recorded temperatures for the last few decades, say from Queensland, Australia to Little Rock, Arkansas, and see which one has been hotter over time and see if you were right, and talk about the why of where with some of the information that we have from this unit. Okay, I look forward to hearing from you and reading more posts on the discussion board, reading those reflection journals. Text me with questions, and I'll see you next time. Bye.